In this video, we're going to talk about solving linear equations. This will be the first of two videos. And in the first video, we're going to look at simple linear equations. And in our second video, they'll get more complicated. But the same rules will apply. Now, what's a linear equation? Well, the linear part means that I'm just going to have an x raised to the first power. So notice I won't have any x squared, x cubes, or anything like that. So x will be to the first power. And the equation part comes from the first four letters in the word equation, and this implies that we're solving things with equal signs, equation equals. And I have two examples here. So for example, I might want to solve x plus 3 equals 12. Or I might want to solve 2x equals negative 24. All right. Whenever I go about solving these, I'm going to have the same goal. All right. And that is just going to be to isolate my variable. Okay, if I get that done, I will have the equation solved. And by isolate, I mean all alone on one side of the equal sign or the other, all by itself. Now we're going to come back and talk about how exactly to solve these in a minute. But right now, let's talk about how we solve them. Now, if you've lived long enough, you probably know the golden rule. The golden rule says treat others the way that you want to be treated. The more formal way of saying it is do unto others as you would have done to you. You may have learned that in Sunday school or from your parents. In math class, the way that we solve linear equations is the golden rule of math. Okay? The golden rule of math says I can do unto one side of the equal sign as you do unto the other. Okay? So if I add something on one side, I'm going to add it to the other. Again, we're looking across the equal sign. If I add something on this side, I got to add the exact same thing to the other. If I multiply something on one side, I got to multiply the exact same thing on the other. Otherwise, I change the equation. You sometimes hear this referred to as balancing the equation. But the bottom line is whatever I do on one side, I have to do the exact same thing on the other. Now, basically, to solve linear equations, we have two things that we'll do. The first is called the addition rule. And what the addition rule says I can add or subtract anything I want from one side, again, of the equal sign, as long as I do the same to the other side, the exact same of the equal sign. And that's where we get at, if I'm going to add 3 here, I need to add 3 here. Okay, and we'll do some concrete examples in a minute. We also have the multiplication rule, which says that I can multiply or divide anything I want on one side of the equal sign as long as I do the same to the other side of the equal sign. This would come into play if I multiplied this side by 3, I'd have to multiply this side by 3. If I divide this side by 2, I'd have to divide this side by 2. Okay? But you can see how the addition or the multiplication rule feed right into our golden rule. Whatever I do on one side, I have to do the exact same thing on the other in order to solve the equation. Now let's go back and look at our examples. Let's first look at the addition rule. Now remember your overall goal. You're going to isolate your variable. Here is my variable. I want it all by itself. Well, I see that I'm currently adding 3. I want to isolate it, so I want to get rid of a positive 3. How do we get rid of a plus 3? In other words, what would I add to positive 3 to make it 0? I would add a negative 3. Or you can think about this as subtracting 3. In other words, we're going to zero out this. And now my golden rule comes into play. If I subtract 3 on this side, I subtract 3 on that side. Again, how did we pick the negative 3? We want to get rid of this. If I add 3, I'm not going to get rid of this. I'm going to end up with 6. Now, sometimes when we write it this way, it confuses students. But in reality, what we're doing is saying plus 3 minus 3. It's as if it's written in one long line. 12 minus 3. Now, we're not going to write it this way going forward, but think about it this way. And we're going to do the math on one side of the equal sign, the math on the other side of the equal sign. So we picked negative 3 because when we add it to 3, it will cancel out. And all that would be left here is my x My equal stays equal. And now on the right-hand side, I have 12 minus 3, which is 9. So that would be my answer. And how do I know I've derived my answer? Because x is isolated all by itself on one side of the equal sign. Let's do one more example. Here I have x minus 9 equals 21. I have a negative 9. How would I zero that out? Well, I pretty much add the opposite. So I'm going to add 9. And whatever I do on one side, I have to do on the other. Negative 9, positive 9, we know that that will go to 0, so they cancel out. I'm left with an x over here. And on the right-hand side, I have 21 plus 9, which would be 30. So again, this would be my answer, x equals 30. How do I know I've arrived at my answer? Because x, my variable, is isolated all by itself. Now keep in mind we're using x, but you can use any variable you like, y, s, t. Now let's use the multiplication rule. When do we know to use the addition rule? When do we know to use the multiplication rule? Well, here we see we're adding 3, so we want to subtract 3 to get rid of it. But when we have a number right next to our variable, the operation implied is multiplication. So how do I undo multiplication? Well, through division. So if I divide by 2, notice that anytime I have the same number over itself, it goes to 1. All right? And whatever I do on one side, I have to do to the other. I'm going to divide by 2. All right? So notice over here, when we had a positive 3 and a negative 3, they went to 0. 2 over 2 does not go to 0. It goes to 1. So over here, I'm left with 1x. Now, we don't write the 1, but we know that that's a 1x. In other words, these cancel out and go to 1. I have my equal sign, and over here I have negative 24 divided by 2. It would give me negative 12. And that would be my answer. Again, I know it's my answer because my variable is isolated all by itself. We have another example. Again, I want to get rid of this number out front. Okay, I know that I'm currently multiplying x by negative 4. So the way we undo multiplication is through division. So I'm just going to divide by that negative 4. Whatever I do on one side, I have to do on the other. If I have the exact same number over itself, it goes to 1. So that leaves me a 1x. And now what happened here? 4 doesn't go into 31, or negative 4 doesn't go into 31. That's okay. My answer is just going to be negative 31 over 4. Keep in mind that as long as I have one negative sign, they all mean the same thing. I can write it this way, like we had it in the beginning. I can write it this way, negative downstairs, negative upstairs, or I can put the negative in front. They all mean the same thing as long as I only have one negative sign. All right, the cool part about all this is you really don't need the teacher to check your answers, because the cool part is you can check your answers. Sometimes it's easier than others, okay? So for example, if I have the correct answer, for example, x equals 9, I should be able to take this 9, plug it in here, and it'll make a true mathematical statement. So if I plug 9 in for x, I'd have 9 plus 3. And I always say, does that equal my 12? Well, that is a true mathematical statement, so I know 9 is the correct answer. Similarly, over here, if I go back to the original problem, it was 2. And if I plug this in for x, I can ask myself, does 2 times negative 12 equal negative 24? Yes, it does. So I know that negative 12 is my answer. Now you can do the same thing down here. Obviously, when we have a fraction, it's not quite as easy, but this one won't be that bad. And now, thus far, we've used the addition rule and we've used the multiplication rule separately. I'm going to end the video doing 3 examples where we're going to use the rules together. Now, primarily, there's always exceptions to every rule, but primarily we're going to apply the addition rule first. So if we have a number here, we're going to get rid of that first. Remember, our goal has not changed. We want to isolate our variable. So in this case, we want to isolate x. And whatever I do on one side of the equal side, I have to do on the other. So I have a positive 3. I want to get rid of that. I'm going to subtract 3 each side. Now this is not a divide, this is a subtract. So what would happen? 2x plus 3 minus 3, the plus 3 and the minus 3 would go to 0, and I'm left with 2x. And on the right-hand side, I would have 21 minus 3, and that would give me 18. Now, I've applied my addition rule, but I still have not isolated x because I have a 2 in front. To isolate my x, now I'm going to divide by 2. Whatever I do on one side, I have to do on the other. The 2 over the 2 goes to 1, so I'm left with 1x. And on the right-hand side, 18 divided by 2 is 9. I like 9 today. All right, and again, we can check. Does 2 times 9, all I'm doing is plugging this in for my variable, plus 3, does that equal 21? Well, 2 times 9 is 18, plus the 3 is 21, so I know I'm correct. Let's go to example number 2. All right, I'm currently, again, we're going to probably apply the addition principle first to get rid of this -7. So I'm currently subtracting 7. To get rid of that, I'm going to add 7. Whatever I do on one side, I have to do on the other. -7, +7 is going to go to 0. Over here, I'm just left with my minus 3x. 18 plus 7 is going to leave me 25. All right, now I still have not solved this because I have not isolated x. I still have a -3. So to get rid of the -3, because I'm multiplying, I want to divide by -3. Whatever I do on one side, do to the other. -3 over -3 goes to a +1, so I'm left with 1x. And over here, 25 over -3 is just going to be -25 over 3. Now, I always get this question, do you want me to simplify this into 8 1/3, -8 1/3? And typically when we're in algebra world, that's what I'll call it, we're going to leave it this way because it's easier to plug this back in and check our answer than it would be this. Okay, so typically, but you want to watch for that and see how they want the answer. If they ask for a mixed number, okay, it will be this. If they ask for a simplified fraction, it would be this. And by simplified, they mean that it is reduced as much as it can be. All right, our last example. Again, I'm subtracting 9, so I'm going to get rid of this first by adding 9 each side. Over here, this goes to 0, and I'm just left with my 5x. -13 +9 gives me a -4. And now to isolate my x, I'm currently multiplying by 5, so I want to divide by 5. Whatever I do on one side, I have to do on the other. This cancels and goes to 1, so I'm left with 1x. And on the right-hand side, -4 over 5. And that cannot be reduced. Okay. So again, these answers make it a little more difficult to check, but we sure could. Notice that the 5 is like a 5 over 1, this. If I multiply it by that fraction, notice what happens. These would cancel, okay, and I'd just be left with a -4. -4 minus 9, does that equal -13? Yes. Okay, so it is correct. So notice that you can get fractions as your answers. They are a little bit more difficult to check, but it still can be done. All right, I hope that this has helped you learn how to solve equations. Again, we're going to solve them using the golden rule. It applies to all equations, whether they're linear or not, but the main thing we want to remember is we do onto one side as we do onto the other.